Welcome to this explainer. Okay, today we're taking a really engaging look at an 8th grade math curriculum, and we're transforming it into a dynamic lesson on space, precision, and purpose. We are drawing directly from a lesson titled The Sacred Measure, Volume of Cylinders and Cones. And you know, what's absolutely fascinating about this particular source material from the Heroesmart Academy is that it doesn't just teach standard geometry. Instead, it actually attempts to bridge the gap between mathematical precision and moral philosophy. It is definitely a unique approach to education, and we're going to break the whole thing down for you step by step.
So, here's our roadmap for today. We'll start with cylinders in our world, then move on to unlocking the volume formula. After that, we'll look at real-world math in action, explore precision, education, and morality, and finally, it'll be your turn to calculate. All right, let's kick things off with Section 1. Cylinders in our world, finding geometry in plain sight.
Right out of the gate, the source material sets the stage for our mathematical journey with the scriptures from 1 Corinthians. By placing this quote right at the absolute beginning of a math lesson, the curriculum makes a very specific point. It's essentially saying that discovering volume isn't just about crunching arbitrary numbers. According to this framework, measuring volume is really about recognizing and finding structural order in our physical world. It frames the actual act of mathematical measurement as a way to understand the underlying decency and order of the universe. But beyond that philosophical framework, the source drives home a super practical message too. Understanding exactly how much space an object holds acts as an incredibly powerful practical tool for making confident decisions, rather than just guessing. Think about it. Whether you're measuring the amount of soda in a typical aluminum can, or maybe designing a giant rainwater barrel to sustain your backyard garden, volume is absolutely crucial. The text emphasizes that mastering this single mathematical concept builds a rock-solid foundation for future careers in fields like science, construction, and architecture. Basically, in both math and life, precision truly matters.
Moving right along to Section 2, unlocking the volume formula, the mechanics of measurement. Let's transition from the foundational theory directly into the mechanics of calculation.
Before we can actually calculate anything, we have to define exactly what we are looking at, right? The curriculum formally recognizes that a cylinder is a three-dimensional shape defined simply by two identical circular bases and the specific height that connects them. So whether it's a soup can in your pantry or a massive skyscraper downtown, if it has a circular bottom, an identical circular top, and goes straight up, boom, you are looking at a cylinder. So, how do we find out exactly how much that cylinder can hold? Well, we use a pretty foolproof three-step procedure that builds our master formula. Step 1, you just take the radius of that circular base and square it. So that's the radius times itself. Step 2, you multiply that result by pi. And finally, step 3, you multiply that whole number by the height of the cylinder. Putting the whole shebang together, we get the classic formula, volume equals pi times radius squared times height. It's a remarkably simple, elegant tool to unlock the capacity of literally any cylinder. Now for Section 3, real-world math in action, applying the formula to everyday objects. Let's see what happens when we use this in the real world. This breakdown brilliantly illustrates how the volume formula works across totally ordinary objects. Take a common tomato soup can, for example. It has a radius of 4 centimeters and a height of 10 centimeters. Plug that right into our formula, so pi times 16 times 10, and we get an approximate volume of 502.65 cubic centimeters. Next up, a water bottle measured in inches yields 226.20 cubic inches. And then, looking at a standard paint can with a radius of 5 inches and a height of 12 inches, the volume jumps all the way up to 942.48 cubic inches. You can clearly see how just tweaking the radius or the height drastically scales the total volume of the object. And that's actually a crucial point, just how incredibly fast volume scales up as the dimensions grow. The curriculum provides a fantastic final example to drive this home: an ordinary household trash bin. It's got a radius of 7 centimeters and a height of 20 centimeters. When you square that radius, getting 49, and then multiply by pi and the height, you yield a massive volume of approximately 3,078.76 cubic centimeters. The math scales perfectly, whether you're dealing with a tiny little juice can or a massive waste bin. Which brings us to the unique educational philosophy of our source. Here is Section 4, Precision, Education, and Morality, the philosophy of the Godly Learners series. Now, the curriculum frames its lessons by contrasting two very distinct paths. On one hand, it argues that education without morality ultimately leads to making bad choices that hurt oneself and others. The source poses a pretty stark question. What's the point of being highly intelligent and supposedly educated if you just continue to make destructive decisions?
On the other hand, the curriculum strongly advocates for education paired with morality, specifically citing Romans chapter 8, verses 6 through 7. The text promises that pairing learning with a spiritual, moral mindset leads directly to peace of mind. Now, as an explainer, we aren't here to endorse this view one way or the other, but rather to impartially show you how this specific curriculum attempts to blend geometric precision with character development.
And finally, Section 5, your turn to calculate. Because practice makes precision. The source material turns the responsibility over to you for some independent practice. Feel free to go ahead and pause this explainer if you want to tackle these 5 homework problems provided directly from the lesson plan. Questions 1, 2, and 4 are pretty straightforward applications of the pi times radius squared times height formula we just learned. But watch out for that tricky third question. Notice how it gives you the base area instead of the radius? You'll have to think carefully about how that puzzle piece fits into the volume formula. And finally, question 5 asks you to get creative. Invent your own cylindrical object, draw it out, and calculate its volume. So that brings us to the end of our explainer. This source material presented a really specific worldview, asserting that precision matters just as much in our mathematical calculations as it does in the moral choices we make in our daily lives. So we'll leave you with this final, provocative thought directly from the curriculum's framing. As you measure the structural order of the world around you, how will you use this knowledge to make better, more deliberate choices moving forward? Thanks so much for joining us, and keep exploring the geometry hiding in plain sight.